vectors. For students who have studied physics, you must be familiar with vectors. But for those who haven't done physics before, you might wonder what vectors are. A vector is basically a moving force. Can you imagine a ball shooting into the, well, in the space, right? If you like push your ball into a certain direction, right? The ball will be moving at the constant speed towards the same direction forever, right? Consider a vector as the force or the ball moving in the space. It's going to a certain direction at certain force. Hence, the distance of the ray in geometric form shows how strong the force is or how fast. So basically, the distance shows how big the magnitude of the vector is. And basically, by putting this ray as the vector, we are also showing in what direction the vector is going at. So again, vectors can be given in geometric form, which means that, we will be using a ray and we will be making either the ray long or short, depending on how strong the magnitude is, and the arrow just simply shows its direction. So consider vector always being defined by its magnitude and its direction. They're both very important. Like for example, even if I do keep like same length, right, with same slope, but if I go to the opposite direction, right, this and this are not the same vectors, okay? This does not equal that because the direction changed. If I keep the direction right, however, shorten the distance, again, this and that are not the same vectors. They're different vectors now. Well, however, though, there are certain rules that you can apply here. So given a vector as v, right? If you do keep the distance as equal, so if the magnitude does equal, right, to the previous one, though it's simply just reversed in direction, right? We actually call that as the negative of the previous vector. So same magnitude but reverse direction means negative of the previous one. And say I'm keeping the direction the same, but I'm using half the length as before. That's technically half of v. So if the vector gets halved, the magnitude gets halved. Okay? If your vector becomes negative, it means that the direction is being reversed. Okay, now, so what if I just randomly draw some vector going at totally different direction? Same distance though. Are they related? No. There are no direct relationship between v and this. Okay. However, we may put two different vectors together and create a new sum, which we call it as resultant vector. That's the name given for the sum vectors between two vectors. So today, to begin with, I'm going to explain about how vectors are added in geometric form. So, okay, so technically, what you need to remember is that the any vector will be defined by its magnitude and the direction. And two, if you reverse the direction of the vector where the distance is still the same, it's basically negative of the previous vector, right? Okay, so vector addition in geometric form. Given two vectors, A and B. Let's see, A is heading this way. B is going up. It's a bit shorter. Now, you may find the sum of the two vectors. If you're confused about this whole process, okay, again, go back to the ball in the space, right? There's a ball going faster than this, though it's going towards this direction. So there's a ball going this way, and there's another ball which is not as fast as the other one since the magnitude is smaller, right? And it's heading this way. So imagine these two balls colliding. What happens then? The thing is, the stronger and then not as strong one will put together, and some of the forces might cancel. So technically, when it comes to adding up two vectors, doesn't really mean that the values are being added on. Depending on where the forces or the vectors are directing it, sometimes you are actually gaining, but sometimes you are losing. If this is not, easy for you to understand, why don't we consider a new example? A ball heading this way, another ball heading towards to the other vector, okay? Imagine if they were going at the same speed, the moment they collide, they will put a stop to each other. They will just like meet, stop, and disappear, right? If they were going towards each other at the same speed, in the space I mean. But if this was going twice as fast as this, right? What will happen? This is much more powerful than this, right? Hence, when they do collide, this will kind of push this, to its direction. Hence, it will just like keep going, though this will slow this down a bit. Do you understand? So again, vector addition doesn't really mean like adding things on. We have to consider the magnitude as well as the directions. So how do we show that resulting, force, the vector? It's quite simple. Excuse me. If you're adding two vectors, just remember this rule, tip to toe. Well, first of all, when a vector is given, we call the point without the arrow, right, as the initial point of the vector, because that's where it starts, right? And we call the one with the arrow part, right, as the terminal point. So, and all you have to do is, in order to find the sum of two vectors, make sure that the initial point and terminal point of another vectors are put together. So technically, this and this will have to put together. So what you do is, you have to draw A and B right on the tip of it. So, sometimes we call this as tip to toe, as in tip to toe, right? So your two vectors, when they are put together, has to be following, okay? It has to go like to the same direction, flowing like that. So technically, we may put the vectors together by connecting this initial by that terminal. That doesn't really matter because, the sum property states that A plus B equals to B plus A, right? And that's true for vectors as well. It doesn't really matter which comes first as long as you're putting the initial and terminal together, okay? So whether you attach these two together or those two together, so if you do attach this by that, then you will be getting, technically, this and then that. So this, right? The reason why this doesn't matter is that, as you can see, and in order to get the sum, what you do is, once you put them together, you have to connect the initial, right, and the terminal of the two vectors together like that, and the sum vector will start from the initial point and it will end with the terminal point, hence in this direction. Okay, again, you start off by the initial point of the first vector and you end with the terminal point of the second vector. I know my picture isn't very accurate, but not drawn to scale. But as you can see, this, right, and this are the same. Why? Direction and the magnitude, the distance, are both equal. Hence, it doesn't really matter whether you attach these two or those two. The sum, will be the same. Hence, the vector in blue is basically your resultant vector, and that is your sum of A and B. As in, well, this was your vector A, right? And this was your vector B, that your vector B and A. Well, that little arrow on top basically is something that we use to show that the letter A here is used to describe a vector. So it's, it's just like arrow with like bottom missing, okay? It doesn't matter. Actually, you can keep that. It's just that, you know, I'm more used to just keeping the top part. But this is totally fine too. So do you kind of understand what we have to do? Let me just give you one more example. What if you had like two vectors, v and w, where v goes like this and w goes like that? Then what is the sum of v and w? Well, again, put them together. How? Can I just put these two together? No. That's initial, that's initial. Those two cannot be put together. So what do we do? Well, we just have to make sure that the initial is put together with a terminal, right? So it doesn't matter which one comes first. If I choose to do this first, then this is my vector v, right? Then I have to attach that here. So I'm actually connecting this by that. And once I'm done, I'm supposed to connect my initial to terminal. So it's going towards this direction, and that is the sum of v and w. Is that clear? Two rows, tip to toe, right? Initial to terminal when you attach the two vectors together, and when you draw your sum vector, again, from initial to terminal. The direction is so important. Again, like for example, if you make the arrow going downward by accident, this isn't the sum. It's actually, in fact, it's negative of the sum, right? Hence, you'll be coming, you know, with a different outcome if you don't keep the direction right. So remember those two rules, tip to toe, initial to terminal. Okay, so this is what a vector is in geometric form. So, you know, again, imagine, you know, balls in the space floating about, okay? So now, let's talk about subtracting. So this is how we find the sum of two vectors. Can we subtract? Is it even possible? Well, actually, we don't do subtraction technically here. What we do is, instead of subtraction, we add a by negative of b. Because you know what I said about reversing the direction to the opposite way means to find the negative of the previous vector, right? So if we still deal with the first example, right? If I'm to find the difference between a and b, what I'm doing is I'm putting this and, here we go, negative b. So I have to keep the distance the same, but reverse the direction, okay? I'm putting these two together. So when I put this and this together so that the terminal and initial meet, so here we go. This is your A still is A. Your negative B now is put here. Is the picture the same? Right? So A and B put together, and the resulting force goes from the vector, goes from initial to terminal. So it will be going from here downwards. That equals to A minus B. Okay, so that's how you find the difference of two vectors. We are actually looking for the sum still, but after reversing the second vector, its direction. Okay, so one more example. If you're looking for v minus w, then what do we do? Since this is w, right? Negative w, so again, this means v plus negative w, right? Negative w goes this way. So when you put this and this together, you get this and this. This is negative w, and this is v. Hence, the sum goes this way. Initial to terminal. So that's v minus w. Isn't that fun? Isn't that interesting? And isn't that also interesting how, you know, when two vectors are added or subtracted, it doesn't really necessarily mean that they are being, you know, like taken, they are not gaining or losing anything, right? Basically, just because it was the sum, it doesn't necessarily mean that the resulting vector is longer than the difference of the two vectors, right? It's got nothing to do with, you know, it's not just about the magnitude. So addition doesn't mean gaining. remember that. And subtraction doesn't mean losing. It's way more complicated than simply adding or subtracting values when it comes to geometrical form vectors. Okay, so some difference and negative of a vector. I hope you now can understand how we can work with vectors in geometric forms. All right, now the next, however, geometric form though is not the only form that we use when it comes to vectors. We do use the components of vectors more often. If you have seen my lecture on parametric equation, I did mention how parametric equations are related to vectors because it shows the horizontal and vertical position separately as two equations. Well, the component, right, of a vector is given by measuring the distance, the horizontal and the vertical distance between the terminal point and the initial point. So technically, since this is the initial point and that is the terminal point, if you measure the horizontal distance between the 2 points, right, that is what your first component represents. That's the horizontal distance. And your second component represents the vertical distance. And so if you see 2, -1, right, and we use this like cute looking pointy brackets here, it means that if you just like simply choose a point as your initial point, right, you will have to go 2 to the right because it's +2. So 2 units, so 1, 2. Then you will have to go 1 unit down because that's -1. And that's where your terminal point will be at. So when you simply connect this to the terminal point, that will give you your vector given by this component. So guys, what we do usually is to understand the component as a graph, we always use the initial. This means we may use the initial as 0, 0 and use this as the terminal and graph it on a regular XY coordinate plane. Oh, excuse me. So if you mark this as 0, 0, and if you mark 2, -1, that's your vector. Okay? That's how you graph a vector in component form. Okay, now, it's just that the component form, it's not only shown in this way. There are two other ways that we show this. One of them is, it's used quite popularly. So again, V, if you have V, okay, here, V as V1, V2, as in horizontal and vertical distance, right? It can also be written as V1I, okay, plus V2J. And here, the I and J basically represents the horizontal, vertical, position of the vector. It means actually nothing but horizontal and vertical. And more importantly, the I here has got nothing to do with the imaginary number I, nothing. It's not the imaginary value here. The I and J simply suggests that the number in front of I is the horizontal and the number in front of J is the vertical position of the terminal point of the vector using 0, 0 as the initial point. And again, I told you two more. And this is actually used a lot in, IB math, IGCSE, the British European math. The vertical form, it can be quite confusing though because, so technically, using our example, I'm saying this can be given as 2I minus J, because that's horizontal, that's vertical, right? As well as 2, -1. But then I don't think you should worry about this form in math subject test because again, I think it's only used in the European math curriculums. But in regular American math books, this is what NCR is. Well, technically we don't use R as -1, but But anyway, this also can be given as a vector. So for students who are planning on taking the SAT subject tests, understand this component form as well as this IJ form and the regular parenthesis form. Okay, so initial and terminal, as in the component as the terminal, initial as the 0, 0. Okay, now, then, is your vector always given in the component form? Well, not really, because remember the previous page? In the previous page, we were playing with vectors in terms of rays, right? We didn't even get a value. Well, and even on a plane, they don't always like give you the component of the vector. Sometimes they actually tell you what the initial and the terminal point of your given vector is. For example, you can say your vector A has an initial point of 1, negative 2 and terminal point of negative 3, 5, right? That means that your vector A starts off with 1, negative 2, so 1, negative 2, so that's your initial point, all the way to 1, 2, 3, negative 3, 1, 2, 3, 4, 5. So somewhere here, right? Initial to terminal, so it goes like that. That's your vector A. Again, oh wait, so does that mean that your vector A has a component of negative 3, 5 because that's the terminal? No. Again, I said you can consider this as terminal because we are considering 0, 0 as initial. Remember what component means? Component means the vertical and horizontal, right? Horizontal and vertical distance between the 2 points. So if you want to find the component of your vector A, knowing the initial and terminal, what you have to do is you need to measure the horizontal and vertical distance between the 2 points. Horizontal distance is, oh, look at this, guys. It goes from 1 to negative 3. What does that mean? It went to the left by 4 units, right? That means negative 4 horizontally, right? Vertically, it goes from negative 2 to positive 5. So it goes up by 7. So that's vertical. Again, so your component of your vector A, right? It isn't this. It is the horizontal and vertical distance between the initial to terminal. Hence, it will be negative 4, 7. Okay, do you understand? From here to there. So 4 from negative 2 to positive 5, hence 7 in total, which we can write it as 4i plus 7j, horizontal, vertical. All right, so that's what a component is. Just please do remember the meaning of V1 and V2. V1, the horizontal distance. V2, the vertical distance between initial and terminal point of a vector. Okay, now let's continue addition and subtraction. We already did addition and subtraction, didn't we? But that was when we had vectors in ray forms, geometric forms, right? Let's talk about adding vectors or subtracting vectors in component forms. Actually, it's so much easier for you to add or subtract vectors in component forms because, all right, so quickly, excuse me, I will give you 2 vectors, vector A as in A1, A2, and vector B as in B1, B2. Horizontal, vertical, okay? So if I were to find A plus B, right? All you have to do is find the sum of the horizontal position. So A1 plus B1 and of the vertical distances. Hence, A2 and B2. So basically, what you have to do is you simply have to add up the numbers in the same position, in the corresponding position values, add them up. That's all you have to do. If you're to subtract them, you simply subtract the numbers in the same position in the order of whatever comes first, right? So you put A1 minus B1, A2 minus B2 as your horizontal and vertical distance between the 2 points, right, of a vector. That's all you have to do. And remember how I said that, if you're given a vector v, and if you halve the distance, it's basically halving the vector itself, right? Imagine having to multiply 1/2 by the vector a. It basically means, if you think about it, if the distance gets halved, right? It's kind of like because of the similarity rule. The horizontal and vertical distance, since this gets halved, will be halved as well. So that basically means having to multiply both A1 and A2 by 1/2, which will give you A1 over 2 and A2 over 2. Okay, here, we will do one last example. So with B though, if you do multiply 2 by B, it simply means multiplying 2 by B1 and B2. Okay? So vector being multiplied by real numbers is really simply done. And actually, there are other things such as dot product, where you have to multiply 2 vectors. However, it's not covered for math subject tests, so I'm going to skip that. When it comes to math subject tests, addition and subtraction, and magnitude of the vector, and sometimes unit vectors, those are the only important concepts that you have to memorize. Well, on top of the general things, such as the component, what it means and all that. Okay, so again, you got this. To add or subtract, we add or subtract the numbers in the same position, okay? The first by first, second by second. And multiplying it by a number means to multiply each of the value by the same factor. Okay, so to summarize it again, a vector v can be given as in v1 and v2, also as v1i plus v2j, which means v1, v2 in vertical form as well, right? Where v1 is the horizontal distance between the 2 points, v2 the vertical distance. And to find the sum of 2 vectors or difference of 2 vectors, add or subtract the values in the corresponding positions. And here we go, the magnitude of a vector. If you're given a vector v, a magnitude, like I was saying before, is the distance of the vector, okay? So if you're given a vector v, we actually use this absolute value sign to represent the magnitude, or sometimes a double. Well, this is more used in, this is the proper in vectors, but we do keep it as the regular absolute value sign as well. So it's the same thing, basically, guys. So magnitude is distance. So how would you look for the distance of vector v, knowing that the horizontal distance is v1 and vertical v2? How are you going to get the distance? You see what this is already, right? What is this? A right-angled triangle. Pythagorean is what you need. All you have to do is find the sum of the squares of v1 and v2 and square root it. That's all you have to do. A unit vector is simply the vector, so a unit vector of vector v, right, is simply the vector itself over its magnitude. Okay? Let me show you an example for these two. If I let my v as something easy, 3 and 4, right? Then the magnitude of it is square root of 9 plus 16, which equals to 5, right? That's the magnitude, really easy. And if I'm looking for the unit vector of vector v, I'm simply doing v over magnitude of v, right? Hence, 3, 4 over 5. And like I said before, if you want half of a vector, you simply half each of the component. If you want to find 1/5 of the vector, all you have to do is simply find 1/5 of 3 and 1/5 of 4. That's your unit vector. So now, some of you might wonder what a unit vector is, because we know what the magnitude is. Magnitude is simply the distance. A unit vector, guys, is basically this. 3, 4 means that, if you start from 0, 0, 1, 2, 3, 1, 2, 3, 4, right? This is your vector v right now. What is the distance right now? The distance right now is 5, isn't it? A unit vector is a vector that has the same direction as the given one, though the distance equals to 1. Unit, right, means that the magnitude, the distance, has to equal 1. The direction, though, should still be the same. So technically, if we use the similarity, since we are trying to find, so consider this as a huge right angle triangle, 3 by 4 as the two legs, right? If you want to find this smaller version of that, where the hypotenuse is 1, since the distance is 1 now, right? What would you do to get the two legs now? You use the similarity. Since the hypotenuse got multiplied by 1 over 5, you need to multiply each leg by 1 over 5. Hence, 3 over 5 and 4 over 5. So again, guys, a unit vector is a vector that goes onto the same direction with distance of 1. That's what it means, and that's why we have to find the magnitude and divide each value by its magnitude, because that's basically what we are doing with the ratio, right? Okay, so 4 things: component, addition, subtraction, magnitude. Important because I think magnitude of a vector is a simple concept, but it does slip the idea, the formula, right, disappear from students' mind at times. So please, don't forget the formula. Do memorize them. And a unit vector, you should remember the formula, but also understand what the meaning of it is, okay? And if you think about it, whenever something in math says a unit, right, it always means that the distance is 1, right? Such as unit circle. What was the meaning of unit circle? Unit circle was just regular circle with center 0, 0 with radius of 1, right? Unit means 1. So unit vector means that the magnitude is 1. Okay? Okay, I think this pretty much covers all the formulas that you have to memorize and understand. So why don't we do a few examples to really so that you can really understand how these formulas are used. So, okay, let's use A and B as the given, vectors. And let's find the unit vector of vector A. And let's find the sum of A and 2B. And finally, find the magnitude of A minus B. All right, unit vector of A, something that we just did. What do we have to do? If you're looking for the unit vector, you first have to find it. To look for the unit vector, guys, you need to first find the magnitude, right? Because a unit vector of A basically means the vector itself over its magnitude. So what is the magnitude then? Square root of first value squared, hence 1, plus the second component squared, hence 4. It's square root of 5. So a unit vector here in this case will be negative 1 over square root of 5, comma 2 over root 5. Where you can rationalize this by multiplying everything by root 5, depending on whether this is listed as the multiple choice or not. Okay, so how do we look for the sum of two vectors, especially when B gets doubled? Well, we do one thing at a time. A is -1, 2. We are adding that by 2b. And in order to find twice the b, we simply have to double up the components given. So 6 and 10, right? Then you look for the sum. And as I have said before, when you're looking for the sum of vectors, all you have to do is simply add up the values in the corresponding position, right? So -1 and 6 are added, hence 5. 2 and 10 are added, hence 12. That is your sum vector. All right, now the magnitude of the difference. In order to find the magnitude of the difference, you want to look for the difference first. Go from the inside, right? So here we go. For C, that was B. A. Okay, here we go. For C, in order to find the, okay, I'm just keeping it a single line. All right, so we need to find the difference first, which is the difference between -1, 2 and 3, 5, right? Subtraction 2. In order to subtract, have to subtract the values in the same position. Horizontal by horizontal, hence -4. Vertical by vertical, hence -3. Ooh, they're both negative. Not a problem. And to find the magnitude of that, you know the formula for magnitude, we already used it over there. Once, we can do it again, is the first component squared plus the second component squared. Sum it, square root it. Ooh, that equals to 25, right? Hence, 5. That's the magnitude of A minus B. Honestly, guys, this is kind of really important, all right? Please do remember. Let me just like mix one more question up. One more. Find magnitude of 2A minus 3B then, right? It might look scary because you might wonder, ooh, what's 2A, what's 3A? What does it mean by find the absolute value of that, right? Again, absolute value means to look for the distance. Get the component, right? You're looking for the distance between the component and 0, 0. Really simple. Now, you just need to figure out what 2A minus 3B is. 2A is twice the value of A, right? Hence, -2, +4. 3B means triple the values, so 9 and 15. And when you subtract, you get -11 and you get, ooh, -11. So this is your difference between 2A and 3B. And to find the magnitude, all you have to do is find the square of each value, right? And then evaluate. That's technically 121 plus 121, which will eventually become 11 root 2. Okay? So, oops. Okay, I'm gonna put a star here, guys. You know, don't panic when you see this, right? Because it's just that I saw many students panicking when they saw this. Don't panic. It's really simple. Deal with this, then use the formula. End of story. Really simple. Okay, so the first part of the questions are done now. Let's move on to the second example. The second example actually requires a little bit more than just vectors. It requires triangle and formulas. Okay, now it says there are two vectors. Oh, interesting. With an initial angle of 30 degrees. Well, first of all, we need to discuss about this. As I have mentioned before, I have skipped some of the terms that you or that you're supposed to learn from pre-calculus in the chapter of vectors, right? Like such as dot product and like that directions and angles and stuff like that, because those are not very covered for the SAT subject test. However, it's not one of those special terms though. This simply means that when two vectors A and B, right, are attached by its both by its initial points, right? The angle, that's initial angle, right, is 30 degrees. It might seem not so important, but guys, we are dealing with vectors. Direction is like, it's something that defines, right? The direction defines the vector. Hence, it's really important that you understand that the 30 degrees is formed when the two vectors are attached in such a way where their initial points are put together. Okay? All right, now, so if, right? Oh, interesting. So your vector A equals to 6j, and the distance of vector B equals to 8, and we are looking for the distance of the sum of A and B. And when it comes to these questions, guys, the thing is, since they are asking about the magnitude, right? What we have to do is, we have to look for the magnitude of vector A and B. B is given. What is the magnitude of vector A? What does 6j mean? 6j means 0, 6, right? Hence, if you want to graph it, it means they're starting from 0, 0, all the way up to 6. That's your vector A. Hence, the magnitude of vector A simply is 6. Okay, now let's put the information together. So okay, so there is a vector A that goes this way, it's 6 long, and there is a vector B which forms 30 degrees from vector A, right? It can actually go that way, it doesn't matter though. And on knowing this, we're supposed to find the magnitude of the sum. What is the sum? Is that the sum? Can we do that? Terminal to terminal? Where do we start from? We cannot do that, right? In order to find the sum of two vectors, we have to make sure that it's initial and terminal attached together. And better yet, what if, right? If you just draw a line parallelly to vector B over here, so just draw another vector B, right? And draw another vector A over here, right? Technically, then whether you choose these two or those two, they're both flowing, right, together. So technically, okay, so this and this as in initial to terminal, or that and that as in initial to terminal, doesn't matter which one you do, will give you the sum vector as in this. So, okay, so let me just like redraw this a little bit nicely. So 6 and 8 and this. A, B, and the sum of A and B. Now, A equals to 6, B equals to 8. So is the sum 14? No, right? Again, as you can see, it's a triangle now. If you're looking for a missing side of a triangle, and it's not a right angle triangle, so we can't use the regular ratio. What can we use for scaling triangle? We can use either law of sine or cosine. Okay, but then however, just knowing two of the sides are not important for us to look for the missing measurement. We need an extra information, one of the angle. Okay, now, here, be careful. This is the reason why I told you to create a parallelogram, because it's easier for you to understand. Guys, remember how this and this put together created 30 degrees? Since it's a parallelogram, the adjacent angle to this, right, should be 150. Well, if you're not sure, if you don't remember why, then just consider this. If that's 30, the opposite angle is 32. And the 4 and this are equal to. Hence, since the 4 vertices should sum to 360, right? Each of the adjacent pair should equal 180 each. That's why. So if this angle equals to 30, this angle should equal 150. And okay, I'm trying to tell you what not to do. So what we did, right? We kind of drew a parallelogram and we cut that in half, didn't we? And you know, some people might think that this is basically cutting the angle in half. Guys, the diagonal of a parallelogram, right, doesn't, okay, bisect the vertex. Doesn't. Okay, could you just remember that? You know, many students do think that it bisects. It doesn't. Diagonals do not bisect the vertex, so we can't keep them as 15. We have no idea what the angle is yet, I mean. The only thing that we can say is that this angle has to equal 150, just because the adjacent angles should sum to 180. Okay, so it doesn't bisect, you know, just like remember that part. Okay, now back to the problem now. 6, 8, and now we have this angle measurement. Can we use law of sine here? In order to use the law of sine, we need like a pair of angle and its opposite side, but we don't have any of that. Hence, we can, now we have to move on to law of cosine. Law of cosine says, if I may call this as x, right? X squared should equal 6 squared, right? Plus a squared minus 2bc, hence 6 times 8, with cosine of 150 degrees. Right? So that's what you have to do. So basically, if you just get the value in your calculator, you know, you will get the proper measurement of your x. Why don't you have fun with it and make sure that you're doing this in degree mode. Okay, so that's 100 and that's 48, so minus 96 times cosine of 150 degrees. Ooh, cosine of 150 is negative cosine of 30, hence that's, but it's kind of ugly, so square root of 100 plus 96 times root 3 over 2. So, I mean, I can't do any further than this, right? You have to do it in your calculator. 80, 48, root 3. So, I mean, you know, you should do this with a calculator, okay? Then you will get the rounded value for your x. So, I think this is probably the most challenging question with vectors, right? Because that, you know, the terms that they use here can really confuse you. Angle of 30, right, means that their two initials are meeting. So to look for the sum, you have to create a parallelogram and cut it like this. Use the diagonal, technically. And the 30 is not going to be used anymore. Instead, we are using the other vertex, 150, right? And you then need to use laws, you know, one of the laws, sine or cosine, depending on what the given informations are, given information is. Okay. So those are the common questions that, you know, are covered in vectors. Oh, except one last thing before we end. Actually, I do think that this is like really fun and simple. Okay, say, guys, you're given like 3 vectors, right? And they're like all attached with each other, like that. And you're to find a correct expression, right, of the relationship between the 3 vectors. So you'll be getting like, well, a plus b equals to c, a minus b equals to c, a, you know, a minus b equals to negative c, bunch of 5 different choices, right? The thing is, if you just find 2 vectors within the 3 that flows, right? Ooh, here we go. B and C, right? You see how B and C added will equal A, right? just to get the proper sum, okay, equation using the current situation. And then what you do is move them around. Now, is the sum A and B? What is the sum of A and B? Well, technically, what is C? What does C equal to? C equals to A minus B. You see what I'm doing? I'm simply subtracting B just because the sum of B and C should equal A. With vectors, you may use the regular arithmetic as as like regular equations. It's totally okay for you to add or subtract, as you usually add or subtract like numbers or variables of an equation. So this isn't right because C should equal A minus B, which means that is the answer. So you could try applying this for, you could try each of the multiple choice with the given vectors, but honestly, if you just come up with the proper format of the equation that shows the relationship and just move it around, it's easier for you to look for the correct equation. All right, here is the, okay, but I'm a little worried about this. Let me just give you one last example. So here, one more. So 1, 2, 3, right? So if I go VST, right? If you want to look for the proper correct relationship between STV, right? All you have to do is, okay, so this and this are flowing. So I'm gonna put vector V plus S should equal vector T, right? Which is correct. And you may look for this from the multiple choice as the answer, but if you don't see it, you may move it around. So you can write it for V, hence you will get T minus S, or you can write this for S, so that you can get S as equal to T minus V, right? Or you may write this for, say, negative S if you want, if you still don't see one of these as the answer choice, which means V minus T. You see how you can just simply move it around, right? And this all mean this. Okay, all right, so that's it. So, for subject tests, you don't have to go too deep, right, into vectors. You don't have to do some crazy position of like two ships colliding, whatever. Here, it's just simple, basic concepts all over. Just remember the little formulas and you'll be fine. All right, so thank you for listening, and okay, I'll see you.